Hello, chemistry students. What we're going to do today is learn what is limiting and excess stoichiometry and how is it just a little bit different than the stoichiometry we've already been doing in chemistry. What we're going to do is we're going to use a little s'more analogy to understand limiting and excess reactants, sometimes called limiting and excess reagents. We're going to follow a recipe where we're going to make some s'mores using 2 squares of graham crackers, 1 marshmallow, 3 rectangles of chocolate. So what if we looked in our house, we had 30 squares, 18 marshmallows, and 24 rectangles of reactants to make our s'mores? Then how many s'mores could we make? Think of it like a synthesis or composition reaction where 2 squares plus 1 marshmallow plus 3 rectangles equals 1 s'more. Which reactant limits your quantity of s'mores? That one's going to be called the limiting reagent, also called a limiting reactant. How much of those other reactants are going to be left over? Those are the excess reagents or excess reactants. Make your prediction now as to how many s'mores we can make. The answer is 8 s'mores can be made. Why is that? Well, the chocolate is going to limit our production of s'mores as products. We're going to have 24 squares divided by 3, which means we can only make 8 s'mores. The marshmallows and the squares of graham crackers will be excess. How many marshmallows are we not going to need? Well, if we only need 1 marshmallow for every s'more, we only need 8. And if we had 18 marshmallows minus 8, we're going to have 10 left over. Next, how many squares of graham crackers are going to be left over? If you need 2 squares, we need to take the fact that we could have made 15 s'mores, but we can only make 8. So 8 times 2 is 16, and then you take 16 minus 30 and you get 14 squares of graham crackers left over. All right, now we have to move into the true chemistry using masses and moles. So when you start a limiting and excess problem in chemistry, you're going to have quantities of all the reactants either in masses or in moles. You're then going to need to find which reactant is completely consumed. You're going to do that by using molar masses if you were given masses to find the moles, and then the mole ratios to determine the limiting reactant, just like we did with our s'mores. For every 2 graham crackers, 1 marshmallow, and 3 rectangles, we could make a s'more. Those were our mole ratios. We're then going to determine the limiting reactant or reagent is the one that's completely consumed, and it's going to limit the production of our theoretical product. Next, the excess reagents or reactants are going to be the ones that are not completely consumed. Typically, we just have 1 limiting, 1 excess, unlike our s'more analogy, which had 3 reactants. So write these down. You're going to need these besides those definitions you can go back and define after you watch the video. So get a piece of paper so you can write down these steps. Step 1, you're going to need to write and balance the equation listing the given and the unknown. Step 2, you're going to need to convert known masses, if you were given masses, into moles using molar masses. Then you're going to use those moles to find the limiting by using mole ratios, just like we did with the s'more analogy. Step 3, we're going to use those mole amounts of the limiting reactant, or mole amount of the limiting reactant, and we're going to compare that with a mole ratio to the desired product. Next, you're going to convert from moles of product back to grams of product, and you're possibly going to have to go back and convert moles to masses for all the excess reactants that you had. Usually it's just 1 reactant that you have to find the excess of, and typically you'll find that by mass. All right, now time for a problem. So what we're going to do is we're going to do a powdered iron metal reacting with chlorine gas, giving off heat and flame. You're going to start with 5 grams of iron and 10 grams of chlorine gas. How much product is produced? You're also going to calculate the unreacted starting material. This is going to be your first limiting excess stoichiometry problem. Make sure you're going to write this down. So the first thing you need is your balanced equation. Here it is. Next step is to find the mole amounts of those reactants, both given in masses. We need to convert them to moles. So 5 grams of iron divided by the molar mass of iron turns into 0.0895 moles of iron. Next, we got to take the other reactant, which was 10 grams of chlorine, divided by the molar mass of diatomic chlorine, and it produces 0.1410 moles of chlorine. Next, we're going to use one of the mole ratios. We're going to use 2 moles of iron for every 3 moles of chlorine and find the moles of chlorine that are possible. If we had 0.0895 moles of iron, we only need 0.134 moles of chlorine. If you look back up in the problem, you have 0.1410 moles. So it's a lot like our marshmallows or our graham crackers. We have more chlorine than we need. So if we have this much iron and we only need this much chlorine, then the limiting is going to be the iron and the excess is going to be the chlorine. Next, we need to use again the mole ratio and start with our limiting mole amount and convert it to the product. So for moles of iron, if it's our limiting, we're going to convert 2 to 2, and we're going to find the moles of iron 3 chloride that we can produce. We then will take that mole amount and convert it to mass using the molar mass off the periodic table added up for iron 3 chloride. Next, I'm going to find the amount of chlorine that was unused. So if I go back to the previous slide, if you look, I'm going to click down to the answer here. If you take 0.1410 and you subtract it from 0.134, you get the 0.007 moles of chlorine unused. So right here, that's where I got the 0.007 moles of chlorine, and then I converted into the mass of chlorine that was left over. Again, this is similar to the marshmallows or the graham crackers, but this is just the mass of it as an excess reactant. So again, 5 grams of iron was used, 9.5 grams of chlorine was used, and we produced 14.5 grams of iron 3 chloride. We're going to check the law of conservation. 5 plus 9.5 gives us 14.5. If you're wondering where I got 9.5, remember I started with 10 grams of chlorine and I have 0.5 left. So don't forget that iron is the limiting and chlorine is the excess, and the 0.5 grams of chlorine is left over. So if I add 0.5 plus 9.5, that goes back to the 10 grams that I started the problem with if I go all the way back to this slide right here. Great job today, chemists. We'll be doing more limiting excess problems tomorrow, but that's enough for today.